So organic chemistry is basically looking at all the different compounds that carbon can form. And carbon is special because it can form bonds with itself to form, long chains of carbon. And it can also form strong bonds with other atoms such as oxygen or chlorine that could be attached to these chains of carbon. So the main class of compounds are the hydrocarbons, which only contain carbon and hydrogen. And these can be saturated or unsaturated. Saturated hydrocarbons are where each bond between the carbon atoms is all single bonds. So each carbon is bonded to 4 different atoms. And these saturated hydrocarbons are called alkanes. And so the first 4 alkanes are methane, CH4. You can see how the carbon is bonded to 4 different hydrogens. And then we have ethane with 2 carbons, propane, which you can see here. Now again, each carbon is bonded to 4 different atoms. And then the butane, which is 4 carbons. So the general formula for all of these alkanes, you can see, if we have n number of carbon atoms, then we have 2n plus 2 number of hydrogen atoms. And beyond butane, you name the alkane by using the prefixes. For example, 5 carbons, which would be pentane, is C5H12. And then we have hexane, heptane, octane, and so on. Only the first 4 have special names. And so, when the carbons are forming a long straight chain, like as you can see here, we call it a normal alkane or a straight chain alkane. And they can all be represented by this structure where n is an integer. So any normal alkane can be represented by just multiplying this middle part. So when n is 0, this isn't here, so we just have 2 of the carbons, and that's ethane. And then if we add one of these, it's propane. Add another, it becomes butane, and so on. And so from butane and other alkanes, higher up, they all show what's called structural isomerism. And isomers are just 2 different molecules that have the same chemical formula, but the atoms are arranged differently. So here you can see 2 different isomers of butane. They both have 4 carbons and 10 hydrogens, but they are arranged in a different shape. Here all the carbons are in a straight line, so this is a normal alkane, and so this isomer is given the name N-butane, where N just means normal. Whereas in this isomer, we have 3 of the carbons are in a straight line, but then one of them is branching off. So this is called a branched chain, alkane, and is given the name isobutane. So butane only has 2 isomers, but as you get more and more carbons, then you get more and more isomers. So there are a few rules for naming any alkane. And you can think of an alkane as consisting of 2 parts. One, the main part, is just a long chain of carbons, which is, kind of the root chain, and then anything hanging off of that main chain is called a substituent. So the number of carbons in the longest continuous chain determines the root name of the compound. And then next we need to describe the substituents, which are again all the things hanging off of this main chain. So if we have an alkane group that is used as a substituent, then the name, we get the name by dropping the A and E at the end and adding YL. So for example, methane becomes methyl. And then we need to specify the locations of these substituent groups. And first, to do that, we have to number the long main chain of carbon atoms. So we give each carbon a number, starting at the end which is closest to the substituent group. We want the substituent groups to have as low as a position number as possible. And then we put a hyphen between the number that indicates the location and the name of the substituent. And in the entire name, all of the substituent names and locations go before the name of the root alkane. And if we have more than one substituent, we write them in alphabetical order. Or if they're identical substituents, we use prefixes, di, chi, and so on. So for example, in this compound, the longest continuous chain are these 4 carbons right here. So the root alkane here is butane, because butane has 4 carbons in its chain. So we number them 1, 2, 3, 4. In this case, it doesn't matter which end we start from, because the substituents are both in the middle. And the substituents are both CH3, which is a methyl group. Now we get it by taking methane, CH4, and dropping one of the hydrogens so it can be attached to these carbons over here. So the substituent groups are at positions 2 and 3, and there are 2 of them, so the name is 2, 3 hyphen dimethyl butane. And as you can see, this is an isomer of hexane because there are 6 carbons and 14 hydrogens. So even though it's an isomer of hexane, hexane does not appear anywhere in the name because the root alkane is butane, since the longest continuous chain is 4 carbon atoms. So here's another example. We want to draw the structure of 4-ethyl 3,5 dimethyl nonane. So the root alkane is nonane, which is the alkane with 9 carbon atoms. So first we draw a chain with 9 carbon atoms and number it. And then we have 2 methyl groups at positions 3 and 5, and then an ethyl group, which is obtained by removing a hydrogen from ethane, which has 2 carbon atoms, and this ethyl group is at position 4. So lastly, we're going to look at some of the types of reactions that alkanes can undergo. Now, under normal conditions, alkanes are usually unreactive because the bonds in them are relatively strong. But when we get to high temperatures, they can undergo combustion reactions with oxygen, which of course produce carbon dioxide and water. 2 other types of reactions include substitution reactions and dehydrogenation reactions. In substitution reactions, one of the hydrogens in the alkane is replaced by another atom, usually a halogen. So in this example, with methane reacting with Cl2, you can see one of the hydrogens is removed and replaced by 1 chlorine atom. And then the hydrogen that was kicked out combines with the leftover chlorine atom to form HCl. In a dehydrogenation reaction, some of the hydrogen atoms are removed from the alkane. So here we have ethane losing 2 hydrogen atoms. And this creates a unsaturated hydrocarbon, because in this leftover compound, the carbons have to be bonded with a double bond instead of a single bond, like we have in saturated hydrocarbons. And we'll talk more about these unsaturated compounds in a later video.